Yeah, hi everyone. Just before we begin, I just want to say a bit about the test one that's coming up on Wednesday. So if you take a look at Learn 2022, you'll see at the bottom of the page, I provided a practice test. So it's exactly the same format as the real test that's going to be on Wednesday, but the questions are just a bit different. Okay, but it's exactly the same format. You're going to get the same style of questions for the test. So it's going to be 45 marks and 1 hour long. So if you do this practice test over the weekend and you can do it within 1 hour, then you'll be perfectly fine on Wednesday. Okay, if you can't do it within an hour, then you've got a bit more practice to do. Okay, so I'll put it up now so that you have Saturday and Sunday to go over it, but we will be going over it again on Monday and Tuesday as a bit of revision. Okay, and then on Wednesday, we're supposed to have the tutorial session, but we're not going to have the tutorial session. Instead, I'm going to be on the Zoom meeting and you can ask any last minute questions about the test. Okay, so instead of having the tutorial session, I have already uploaded the tutorial solution, so you can have a look at that as well. Okay, are there any questions about that plan? Okay, if you do have any questions later on, you know how to contact me. So today we're going to finish off U Substitution. So we've spent a lot of time looking at indefinite integrals, and I just have an example here, a classic example with U Substitution. So we have the integral of cos pi over 2 times x. Now we know we can't do this right away because we know how to integrate cos of x. We don't know how to integrate cos of pi over 2 times x. So to help with that, we make this U substitution. So we know that the inside function is pi over 2 times x. So we say u is equal to pi over 2 times x. So that's the first thing. Then we need to find du, do a bit of manipulation, substitute back, and then we get this easy integral in terms of u. So this one's easy to do. Okay, we do the integral, but then remember, we can't leave it in terms of u. We need to go back to x. So we go back to x here. And don't forget, whenever you're doing indefinite integrals, you always need to add c. So this is for indefinite integrals. Okay, so we've spent a lot of time looking at these. So what we're going to do today is look at how do we do U substitutions with definite integrals. Remember those from last week when we did FTC part 2. Okay, so what happens if we have an integral that looks like this? So it's the same integral as before, cos of pi over 2x, right? But now we've got a lower bound and we've got an upper bound. How do we deal with this? So everything stays exactly the same as before, exactly the same procedure, but now we just have one extra step because we have to deal with the upper and lower bounds. So I'm just going to rewrite this to make it very clear what I mean. So remember that the lower bound and the upper bound are x values. Okay, they're x variables. So at the bottom, we have the integral as x equals 0 up to x equals 1. And then we have cos pi over 2x dx. So we see that this is an x value and the upper bound is also an x value. So the reason I'm stressing it like this is because when we do the U substitution, we need to change all of the x values into u values. So we have to change pi over 2 times x into u. We need to change dx into du. We also need to change the bounds. So let's just make a little checklist of the things we need to do. Okay, so we need to firstly do our U substitution. So U is going to be equal to pi over 2 times x. Okay, I'm sure everyone has spotted that. Then the second thing that we did last time was we found du. So remember, du is du by dx dx. So that means du is going to be pi over 2 dx, and that means 2 over pi du is equal to dx. That's the second thing. But now we have a third thing where we have to change the bounds. So let's do that. So the lower bound was x equals 0. So what we need to do is take this x equals 0 and substitute it into our transformation equation. So when x is equal to 0, we now have that u is equal to 0, because pi over 2 times 0 is 0. So let's write that in here. So this is going to be, wrong color. This is going to be pi over 2 times 0, and that's going to give us 0 for the lower bound. So this becomes our new lower bound. Okay, and what about the upper bound? The upper bound was x equals 1. So what does the new upper bound become? Well, u is now going to be pi over 2 times 1. So this will be pi over 2. This becomes our new upper bound. Okay. So previously we had the first 2 steps, but now if we are dealing with a definite integral, we have a third step. Okay, so it's just one more step that we need to add. Are there any questions about this third step? Okay, so let's do our replacements like we did before. So the old integral went from x equals 0 to x equals 1. We had cos of pi over 2x dx. And now we've got the new integral. So this is the integral from u equals 0 to u equals pi over 2. And then we're going to have cos of u, and then 2 over pi du. And then we can rewrite this as 2 over pi, the integral from 0 to pi over 2, cos of u du. So we get a new integral instead of the old one. And notice how the bounds have changed. They were going from 0 to 1. Those were the x bounds. Now the u bounds are from 0 to pi over 2. Okay, so that's the change that we need to do. Okay, are there any questions so far? Okay, so let's do the new integral. So we have 2 over pi, the integral from 0 to pi over 2, cos of u du. This is going to be 2 over pi, and we use FTC part 2. So the integral of cos is sine, and then we're going from 0 to pi over 2. So this is going to become 2 over pi. We evaluate the antiderivative at the upper bound. So we're going to have sine of pi over 2 minus the antiderivative at the lower bound. So sine of 0. And then we just simplify. So this is going to be 2 over pi. Sine of pi over 2, that's going to be 1. Sine of 0, that's 0. So this just becomes 2 over pi. Yeah, and that's our final answer. Okay, any questions yet? Okay, so it's not too bad. It's exactly the same as what we've been doing throughout the week, but we just have this extra step 3, this bit over here, extra step. Okay, so we've got this extra step here where we need to change the bounds. Okay, that's the only extra thing that you need to worry about. Everything else is exactly the same. Okay, let's take a look at some more examples. Okay, so that's example number 2. So we have the integral from 0 to 1, 3t minus 1 to the 50 dt. Okay, so step 1 is to let u be something. So u, let's do it in blue, u equals something. What should we let u be in this case? Any ideas? (3t minus 1). Perfect. So u is equal to 3t minus 1. Okay, so that's step 1. Step 2, we need to find du. So du is going to be du by dt, dt. So this is going to be equal to, what are we going to have for that? Okay, so what is du going to be in this case? 3. Yeah, exactly. So it's going to be 3 dt. Okay, but we've got a bit of a problem here. So we're not done yet. What is the next step that we need to do? We have a little problem with this 3 here. So what do we do next? Yeah, so we're going to have 1 over 3 du equals dt. Because we have a dt here, we need a dt here. Okay, good. That's step 2. But now if we're working with definite integrals, we also have a step 3. That's where we change the bounds. So if x is equal to 0, u is equal to, what is the new lower bound going to be? Sorry, not x, sorry, that's t. Sorry, we're working with t. So t is equal to 0, u is equal to minus 1. Yeah, you got it. Okay, and that's the lower bound, and now the upper bound. T is equal to 1. So u is equal to, what's the new upper bound going to be? Two. Good. Okay, so we've done step 1, step 2, step 3. We can plug everything into our equation, into our integral. So now we have the integral. The new lower bound is minus 1. The new upper bound is 2. 3t minus 1, well, that's going to become u. So it will be u to the 50. And dt is going to become 1/3 du. So just rewrite that, 1/3 du. Okay, so that's the new integral. So let's evaluate that. So this will be 1/3, the integral from minus 1 to 2, u to the 50 du. And now we just use the power rule as we did before. So this is going to become 1/3, 1 over 51, u to the 51, from -1 to 2. Okay, so we're going to have 1 over 3 times 51. That's 1 over 153. 2 to the 51. If we evaluate that, you don't need to simplify that. Please just leave it as like 2 to the 51. But then we're going to have minus 1 to the 51. But -1 to an odd number is going to be -1. So it's going to be minus 1. So we're going to end up with +1. So it will be 1 over 153, 2 to the 51, +1. And then you can leave it like that. Don't worry about simplifying. Okay, so you see we get a number at the end, which is what we expect because this is a definite integral. So no plus c, no functions, nothing like that. We just get a number at the end. Okay, any questions about this example? Okay, so it's almost exactly the same as what we've been covering before. Okay, just small little extra bits. Let's take a look at another example. Number 3. Okay, so we've got the integral from 0 to the square root of pi, x cos x squared dx. Okay, so that's the integral. Remember step 1, step 2, step 3. So step 1, u is equal to something. What should u be equal to in this case? Any ideas? Okay, so we're looking for some inside function. U is equal to x squared. Yeah, you got it. Okay, so u is equal to x squared. Yeah, cool. Everyone's getting it now. Okay, so that's step 1, done. Step 2, we need to find du. So remember, du is du by dx dx. So du is equal to, what should I fill in there? 2x. Yeah, you got it. 2x dx. Okay, but we've got a bit of a problem here. We've got a 2x dx, but in the original integral, we just have x dx. So what do we need to do?
So you can divide by 2 on both sides.
Yeah, that's right. So divide by 2 on both sides. So we have 1/2 du is equal to x dx. And that's perfect because that's what we have there. Okay, cool. Step 2 is done. Now we need step 3. So we need to change the bounds. So when x is equal to 0, u is going to be, what are we going to have? Okay, so the old lower bound was x equals 0. We're looking for the new lower bound. So what do we get? Zero. Yeah, you got it. Good. And now we need the upper bound. So when x is equal to the square root of pi, the new upper bound is going to be, what are we going to get?
Pi.
Yeah, that's right. Okay, so we've got all the pieces that we need. Yeah, everyone, yeah, in the chat, that's correct. Cool, so we've got everything we need. So the new integral will be the integral. The new lower bound is 0. The new upper bound is pi. Cos of x squared will now just become cos of u. And x dx, that's this thing over here, that will just be 1/2 du. Okay, so I've done the replacement there. Okay, so we can take the 1/2 out. So it's 1/2 the integral from 0 to pi, cos of u du. Okay, so now we can integrate. So that's going to be 1/2. The integral of cos, that's going to be sine from 0 to pi. Okay, and then we can substitute in. So we're going to have 1/2 sine of pi minus sine of 0. But that's going to be 1/2 of sine of pi is 0. Sine of 0 is also 0. So we get 0 at the end. Okay, so again, we went from a complicated integral to a simple integral. But remember that we have to change the bounds. So that's the only thing you need to remember for these definite integrals. Okay, any questions so far? Yeah. Let's do example number 4. Okay, example number 4. So this one's a little bit more difficult. So we have the integral from 0 to 1, 1 over 1 plus root x to the power 4. Let me just rewrite that. That's a 4 dx. Okay, so we've got this integral. Exactly the same procedure as we've had before. So number 1, u is equal to something. What do we have for that?
1 plus root x.
Yeah, perfect. Okay, so we've got that. Then we need to find du. So that is du by dx dx. So du is going to be, we take the derivative. So remember, this is x to the 1/2. So we take the 1/2 down, we minus 1. So you can check this, but in the end, we get 1 over 2 root x dx. Okay, but we've got a little bit of a problem here. Put a little exclamation mark. We've got a problem here because in the question, we only have dx. But here we've got 1 over 2 root x dx. We've got this extra bit in front. So we need to take that over to the other side. Okay, but you'll see there's a little bit of an issue with that. So let's take it across first. So we're going to have 2 root x du is equal to dx. Okay, now this looks all right, but we have a problem. Here we have root x. So that's an x variable term. But right next to it, we have du. So there's a clash of variables. Okay, you can't have something with x and then du. That's not going to work. So what we need to do is replace this root x with something that is a function of u. Okay, so how do we do that? Well, look back at our original expression for u. If we just do this on the side here, u is equal to 1 minus root x. 1 plus root x. What we want is to solve for root x. So u minus 1 is equal to root x. So that's what we can use to fix this problem that we're having. So we're going to have 2 u minus 1 du is equal to dx. Now this is fixed because everything on the left-hand side is u, everything on the right-hand side is x, and that's good. So that's good now. Okay, are there any questions about what I did there? Okay, cool. So that was step 2 done. Now we need to do step 3 where we change the bounds. So step 3, the old lower bound was x is equal to 0. So the new lower bound is going to be what? What are we going to get for that? Okay, so the old value is x. The new u value is going to be 1. Yeah, good. Okay, I've got a question here to re-explain part 2. Okay, I'll do that now. Let me just finish with the upper bound. So the old upper bound was x equals 1. And the new upper bound is going to be, what are we going to get? 2. Yeah, you got it. Okay, so that part's done. Okay, so let me just re-explain this part 2 again. Okay, so let me just do it on the side here. This is part 2. So we know that u is equal to 1 plus root x. Okay, that was because it's this inside function that's causing us problems. So we need to find du, to write the new integral. So you can check this, but du is 1 over 2 root x dx. Okay, so that's just taking the derivative. But this is a problem because in our integral, we only have dx. Over here, we've got 1 over 2 root x times dx. So we need to get rid of that. So it's exactly the same as what we did in the previous examples. We take it over to the other side. So we're going to get 2 root x du is equal to dx. Okay, so we just took it over to the other side, no problem with that. But we have a problem because take a look at the left-hand side now. We've got 2 root x, so that is an x term. But du is a u term. So there is a clash with the variables. Okay, so we've got a clash here. Okay, so we need to try and fix that. So what we need to do is we want to write root x in terms of u. That will fix everything, because if we can write root x in terms of u, then the left-hand side will be only u variables, and the right-hand side will only be x, which is what we want. So how do we fix that? So we need to find this. So we look back at our original equation here. U is equal to 1 plus root x. So if we take the 1 to the other side, we get u minus 1 is equal to root x. That's exactly what we need. So instead of root x, I'm going to replace it with u minus 1. So we're going to have 2 times u minus 1 du is equal to dx. Now the left-hand side only has u variables, okay, which is what we need. Yeah, so we fixed that problem. Is that all right? Okay, cool. I will put up more homework questions with this type of manipulation, and then you can get used to that. Okay, so we've got everything we need now. So let's write out our new integral. So the old lower bound was 0. The new lower bound is 1. The old lower bound was 1. The new lower bound is 2. Okay. And then 1 over 1 plus root x to the 4. Remember, 1 plus root x is now going to be u. So it's going to be 1 over u to the 4. Okay. And then dx, we just look here. Dx is going to be 2 times u minus 1 du. Okay, so I've just substituted everything in. So let's fix this up a bit. So the 2 we can take outside because it's a constant. Then we have the integral from 1 to 2, u minus 1 over u to the 4 du. Okay. So now we can separate the fractions out just to make things a bit easier. So this will be 2, the integral from 1 to 2, u over u to the 4 minus 1 over u to the 4 du. Okay, so I've separated it out. Now we can simplify. So this will be 2, integral from 1 to 2. U to the 1 over u to the 4, we are going to have a u to the power 3 in the denominator. But remember, we want to work with the power rule, so we're going to write this as u to the minus 3. Similarly, for the other term, we've got u to the power 4 in the denominator, but we want to work with the power rule, so let's take it to the top. And then we have u to the minus 4 du. Okay, so now we can use the power rule. We add 1 to the exponent to make it minus 2, and then divide by minus 2. So we're going to have minus 1/2 u to the minus 2. Next, we have a minus 4. We add 1 to make it minus 3, and then divide by minus 3. But then the minus and the minus will make a plus. So we're going to have plus 1/3 u to the minus 3. Evaluates it from 1 to 2. Good, so all of the integration is done. We just need to substitute now. So this is going to be 2 into, let's substitute the 2 first. So we're going to have minus 1/2 times 2 to the minus 2, that's going to be 1/4. Plus 1/3, 2 to the minus 3, that's going to be 1/8. Okay, then we need to subtract the lower bound. So it's going to be minus, in brackets, if I substitute 1, I'm going to get minus 1/2. And again, if I substitute 1, I get plus 1/3. Okay, good. So let's write everything out. So this is going to be 2 times minus 1/2 times 1/4. That's going to be minus 1/8. Okay, 1/3 times 1/8. That's going to be 1 over 24. Then we're going to have plus 1/2 and minus 1/3. Okay, so that's just writing everything out nicely. So this is going to be 2 times. If we want to add all of this together, we should have a common denominator. So let's make that 24. So how do we get from 8 to 24? We times by 3. So this is minus 3 over 24, plus 1 over 24, plus 12 over 24, minus 8 over 24. Okay, so that's 2 times. 12 minus 8, that's going to be 4. Minus 3 is going to be 1. Plus 1 is going to be 2. So we have 2 over 24. So then that gives us 4 over 24. Okay. And then you can simplify that more if you want to, but I'm just going to leave it like that. Okay. Are there any questions so far? Okay, so everyone's okay with this U substitution with definite integrals. Okay, so it's not a big section for test 1 that's coming up. You can have a look at the practice test to see how much it's out of. So for now, it's not a big section, but later on, you'll be using it quite a bit. Okay, so it's good to get lots of practice now. Okay, so let me just leave you with some homework. And then like last time, I will just upload the solutions this evening. So there's just one question today. So we have the integral from 0 to 1, the square root of 1 plus x squared times x to the 5 dx. Okay. So that's all the homework for today. So try this out, see what you get. If you have questions, you can email me or WhatsApp me. And then later today, I will upload the solutions. Okay, so just one question for today. But please, for this weekend, you've got some extra homework on top of this. So Saturday and Sunday, please go through the practice test, see how much you can do. And also, please time yourselves. So it's out of 45, and I'm giving you 1 hour. And then you'll have half an hour to scan and upload as well. But try to see if you can do it in 1 hour. If you can't, then you've got a bit more practice to do. But if you can do it in under an hour, then you're going to be perfectly fine for the test. Okay, are there any questions about the test? Anything to do with the scope or anything like that? Okay, any questions about today's lecture? Okay, so we're going to leave it at that for today, and then I will see you on Monday for the test revision. Okay, and if you have any questions about the practice test while you're going through it this weekend, you can also just email me or WhatsApp me, and then I can help you out. But try and do the practice test without looking at your notes, just to have those test conditions, and then you can have a look at the solutions on Monday and Tuesday. Okay. Have a good weekend, everyone, and I'll see you on Monday. Bye.